Look up at the night sky. Every star you see is a cosmic factory, forging elements in its blazing heart. The carbon in your cells, the iron in your blood, the oxygen you breathe, all were cooked inside stars that lived and died long before our sun was born. To make these elements, nature uses unimaginable heat and pressure. But what if we could bring a piece of that star power down to Earth? What if we could build our own miniature star forges? Welcome to Boson Buzz. I'm Monty Molecule, and today we're venturing into laboratories where they don't just study the universe's recipes, they use them. We're meeting the masters of extreme creation, the stellar forges. Imagine we need a new alloy for a spacecraft hull that can withstand the intense radiation and heat of a journey to Jupiter's moons, or a coating for a fusion reactor that can survive conditions hotter than the sun. The periodic table has only about 90 stable elements to work with. Combining them the usual way, melting them together in a furnace, often gives us ordinary materials. To get extraordinary ones, we need to mimic nature's most extreme workshop, the heart of a star. The old approach to studying these conditions is indirect. Scientists use massive particle accelerators to smash atoms together at incredible speeds, creating fleeting superhot sparks of energy to study. Or they rely on computer simulations, which are powerful predictions but aren't the real thing. To truly create and test new star-forged materials, we need to actually make those conditions here and hold them steady long enough to work. Enter the Stellar Forge. Modern labs are building two incredible machines to do just that. The first is the ultra-powerful pulsed laser. Imagine focusing the light of every lamp in a major city into a single point for a fraction of a second. These lasers fire pulses so intense and so fast that when they hit a tiny pellet of material, they don't just melt it, they vaporize it instantly into a plasma hotter than the sun's core. For that brief, brilliant moment, we have a star on Earth. The second machine is the diamond anvil cell, but taken to a whole new level. Think of it as the world's most powerful vice. It uses two tiny, super strong diamond tips to squeeze a speck of material. But now, scientists are combining this with incredible heat, using lasers to cook the sample while it's being crushed. This can simulate the intense pressures at the center of giant planets or the crushing depths within a star. Inside these forges, amazing things happen. Normal rules of chemistry break down. Atoms are stripped of their electrons, creating that fourth state of matter, plasma. Elements that would never mix under normal conditions, like iron and helium, can be forced together. We can create exotic states of matter, like metallic hydrogen, which might be a room-temperature superconductor, a material that conducts electricity with zero loss. Or we can form super-dense, super-hard crystals that could be used to make drill bits that never wear out or ultra-efficient solar panels. But perhaps the most exciting goal is to master the ultimate stellar recipe, nuclear fusion. The sun and stars power themselves by fusing hydrogen atoms into helium, releasing vast energy. Our stellar forges, especially the giant laser facilities, are the training grounds to learn how to control this process. By perfecting how we ignite and contain these microstars, we're working towards fusion power plants that could provide limitless, clean energy for our civilization. Let's see the forge in action for a new material. A team needs a new type of radiation shield. They load a small, perfect sphere of a mixture of metals into the target chamber of a giant laser. The room is cleared. A countdown begins. At 0, dozens of laser beams converge on the pellet from all directions. There's a flash of light brighter than 1,000 suns, captured by ultra-high-speed cameras. For a few nanoseconds at the pinpoint center, the temperature soars to millions of degrees and the pressure is billions of times Earth's atmosphere. In that stellar flash, the atoms of the different metals are completely broken apart and then refused into a new, unified structure. When the plasma cools and condenses, it leaves behind a speck of a new material. Under the microscope, its atomic structure is unlike anything found in nature, a lattice designed by star-like fire. This speck is then tested. It might be 1,000 times more resistant to radiation damage than any existing metal, making it the perfect candidate to protect astronauts or contain fusion reactions. The future shaped by these forges is one of designed matter. We could create alloys for airplanes that are half the weight but twice as strong, dramatically reducing fuel use. We could synthesize materials that efficiently convert waste heat from engines back into electricity. We might even discover new superconducting materials that work at everyday temperatures, revolutionizing how we transmit power and build computers, all because we learned to cook with starfire. Looking further ahead, the ultimate stellar forge might be the key to deep space exploration. If we can reliably achieve and control fusion, we could build engines that use tiny, contained starbursts as propulsion. A spacecraft powered by a microsun could carry us to other star systems within a human lifetime, turning the dream of interstellar travel into a reality forged here at home. It redefines our reach, doesn't it? We're no longer limited to the materials we find. We can learn to make the materials we dream of, using the universe's own most powerful tools. It's the promise of clean energy from miniature suns, of materials born in extreme fire, and of a future built with the very fabric of the stars. If the idea of earthbound star forges ignites your curiosity, please like and subscribe to Boson Buzz. Until next time, have a safe and curious week.